this is great. Great information, very inspiring. I mean, it really lights up your brain.
Yeah.
But when our foundation members meet once every 2 or 3 months,
No, we'll have
there's
it.
no continuity.
I got it. So let me get this. I'll get this by the June 5th meeting.
Cool.
This plus other stuff.
Yeah. I could see, I would love for us members,
Yeah.
foundation, to become ambassadors and
Oh, yeah.
learn this information.
Absolutely.
Every time we sit down with our neighbors and friends, I think that's the only way to get the word out.
And hold the standard up here,
Yeah,
not down here.
exactly. I had another, real quick, when you were talking about you can go in, you can check in at the hotel now without talking to people. Our wife and I were on a road trip a couple months ago. We were decided we need to find a place to put the RV in about 2 hours. Checked on the phone, found the park, checked spaces available, walked it in, paid for it, and we're still 200 miles away.
I know. Isn't that amazing?
Not talking to anybody.
I hear you. I'll see you later.
That's very good program. Thank you.
Okay, if you could return to your tables. Okay, I think we're ready to get started. If you could return to your tables. Okay, the next part of our program involves our Siemens tag team, but led by Hunter back here, joined with Matthew Thornton and with Brian Taylor. I think you guys got the background on all three of these gentlemen. You may know that Siemens employs 67,000 employees in the United States and 350,000 worldwide. They're the leaders in medical and max trains and other forms of technology. However, today we're going to focus on industrial automation business. And they will discuss in this process the applied changes now underway which are transforming the workplace. They'll discuss the expectations that Siemens and Boeing and other companies expect from institutions in terms of training that are designed for the future. And finally, they'll discuss how Siemens is working with Clark and with other partners to build a program to serve industry far into the future. So, Hunter. Thank you.
That video always seems to make me seem a little cooler before I come on stage and I talk to people. So I don't. I promise at the end of the day, I'm just a nerd that's very passionate about technology, and that's a bit what I'm going to focus on today. So I hope you find it interesting. But for many of you, I met you last night. If I didn't, then please come and introduce yourself. We'll be here for lunch as well. But my name's Hunter Beck. As Brad mentioned, I work for Siemens. I go by a few different titles nowadays because they seem to continue changing them for no apparent reason. But either analyst or solutions consultant or that guy that needs to get something done or put out a fire, whatever has to happen. I'm part of our global digital enterprise group, and somehow we're tasked with making sense of what we're seeing happening in industry with digitalization, this combination of software and hardware that's really revolutionizing the way many of our customers are going to market now and internally doing things with their companies. So I think, is there a clicker up here? Okay, so this one. The other one. This one, okay, cool, the big green button. That helps. But I want to take a step back before we go through a little bit of the technology to something a little bit more relatable, or at least to many of you. I happen to not be around when this invention came to life. Though my, I apologize. Though my generation is bringing this back, though. I'm sure you're seeing a little bit of that. So obviously, records were actually a huge innovation at the time that they were beginning to be produced, because it gave us an opportunity to mass produce digital media, digital in the form of a hard vinyl record, but fundamentally digital media, and distribute it to the masses, right? And that was a huge technology change at the time. But then, and there were a few short-lived other media forms in between here, including cassettes and others, but CDs took hold for a period of time as well. And now, this I do remember, going into music stores, right, and you'd pilfer through all the CDs, you'd pop one into a player, you'd listen to it on some headphones, and you'd decide which album you wanted to buy. Backstreet Boys or NSYNC or whatever it was in the 90s while I was growing up. So. And that, again, was a huge revolution in the way we were able to listen to music. One, the amount of data that you could hold on these was significantly more, and the price began to drop, and it allowed you to actually bring around your really cool-looking Walkman to listen to your cassette tapes, or then they internally revolutionized and started to be able to play even CDs. But now, today, you're not going to find very many CDs laying around. And that's because we have new digital storage techniques that are allowing us to carry around millions and millions of songs on our phone. And even that, though, you may have recognized over the last few years has changed. So we're no longer buying our music. We're buying it as a service. So now with applications like Spotify or Apple Music, you just pay a monthly subscription and you have access to all the music you could ever want and more. And even beyond that, what you may not realize those services are doing is, like Spotify, they collect your music listening history, and they analyze that, and they say, this is what we think you'll want to listen to next. And they start propagating playlists for you, kind of tailoring it just for you based on your listening history. Or even when you go on a run now, it can match the pace of your run with the music, so the music is encouraging you to hit a certain step per minute. And even furthermore, and I actually just realized this a couple weeks ago that Spotify has begun doing this, which is that they'll take your music listening history and say, you seem to listen to a lot of artist X. And they'll say, well, we know when that artist's next performances are coming up, and they'll begin recommending which live performances you should go to as well. So I happen to be from Texas, so I went to Austin City Limits. It's a big music festival there every year, pretty much every year for quite some time. And because of that, because I lived in Austin and because I happened to listen to a particular artist, Hozier, doesn't matter, and they said, hey, by the way, they popped up a notification unprompted and said, by the way, this artist is going to be playing at this music festival. Their tickets just went on sale. You should check it out. And so these are the type of innovations we're seeing impacting us in our day-to-day life. And you would expect that industry, every manufacturing facility you go into is just highly roboticized and everything's perfect. There's not a human walking around, and that's simply not the fact of the matter. It takes a bit longer for industry to adopt these sort of new technologies and innovations. but they are happening. And Brad, I think, did a fantastic job giving a recap of how Industry 4.0 came to life. So I won't go much through the history of it, but what I do want to point out is a couple things. So we weren't really around for the first industrial revolution that he mentioned that was really propagated by steam power. But the advent of the second industrial revolution and electricity, we were there. And in fact, our founder started Siemens in 1847. So we've been around for quite a long time. In fact, Werner von Siemens is considered one of the founding fathers of electricity and modern electrical theory. In fact, the name Siemens is actually a unit of energy in circuit theory. Won't go into that one, though. And then in the third industrial revolution, which was really led by this idea of starting to bring computers, which were hitting the consumer market, onto the manufacturing floor. So a gentleman named Bob Morsey had this idea to come to essentially create a rugged computer that could be used for manufacturing facilities as well. And that propagated a whole new change. But in Industry 3.0, we started to see changes like adding a significant amount more of robotics and machines that were capable of much more complex tasks. But again, that's all Industry 3.0. That is, quite frankly, not that it's the way of the past. There are many people that have not reached that state yet, but at the very least, it's technology that's been quite mature for some time, and it's not what we believe is going to propagate Industry 4.0, which is this next revolution that's happening today. And there's a number of reasons why we're seeing digitalization happening in industry and in our personal lives. One of those is demographic changes. So the population is increasingly aging, and it's causing a retirement of the most skilled individuals that have been in the workforce for a significant period of time. And as individuals like myself are joining the workforce, not knowing at all what we're doing, it's causing an issue in skilled labor that some of which Brad was mentioning. And because of that, we need to address those shortages of labor, though that's something I'm sure all of you are much more familiar with than I am. Secondly, in climate change. I won't get into the politics of it. However, I will say that consumers are increasingly concerned about climate change and sustainability of products, not just the production of them, but how that product life cycle is. So what happens when you throw it in the trash as well? And so we have to consider the way we make our products in a completely new light. Urbanization, this is causing a significant amount of GDP growth, but it's also just causing the type of trends we see, the type of consumer activity we see. And additionally, a pretty impactful one here is globalization. So the amount of data that's crossing over international borders has increased by 50-fold over the last 10 years. And in doing so, what this means is if Rihanna tweets something about a new album today, that hits every single country within the next 5 minutes, right? And so now trends are beginning to happen faster and faster and faster. And for industry to keep up with that, they have to completely rethink the way they're doing business today. But the most fundamental of these that we've seen is digital transformation. So this is being driven by a number of different things. One of those is the number of connected devices. We call this the Internet of Things, right? And connected devices could be absolutely anything. It could be your smartwatch, your phone, your thermostat now. I have Hue light bulbs in my apartment, so now my light bulbs are even connected to the internet, right? And with all of these new connected devices, we have a significant amount of data that's being produced from them. In fact, they're projecting by 2020 that we'll have over 40 zettabytes of data. That's like 10 to the 9th terabytes, which is a mind-bogglingly huge amount of data, basically. But I'm going to teach you a few new terms throughout the presentation. So, regardless, what this means, though, is that we need to be able to approach the analytics of this data, utilizing this data in new ways so that we can gain insight from it. Because I could give you a spreadsheet with 40 zettabytes of data points on it, but I guarantee you, you wouldn't be able to make any sense of it on your own without the use of some of these new technologies that are coming out today. And because of all these things, we're quite confident that digitalization is really going to change everything about the way industry works. And we're not the only ones that think this. Michael Dell, the founder of Dell, has mentioned that the next $1 trillion is going to be made with data. I'd like a small piece of that if possible. And additionally, though, and Brad, I think, actually was pointing this out, and your statistic was even a bit more shocking, right? That 88% of companies, but even in just the last, just since 2000, we've seen over half of those companies disappear. And that's a scary figure for manufacturers that have been around for quite a long time, ourselves included, right? You can't count on just the fact that you've been around for over 100 years to continue to propagate you into the next 100 years. And we saw this happening as Siemens, and we decided to go in all out. So over the last 10 years, we've invested over $10 billion in acquiring a variety of different software companies in different spaces. Many of these are simulation companies and product lifecycle management platforms, electronics. There's a huge spread of different companies that are on there. But the point is, we were so confident in the fact that digitalization was going to impact our customers that we were willing to spend $10 billion on reforming ourselves internally and how we're capable to go to market. And in fact, a fact that I like to point out now, though, is that so Siemens has been around for a very long time. We've always been a hardware company. We're a hardware and services company, fundamentally. As of the end of this year, assuming numbers are, that all the numbers roll out appropriately, with the newest acquisitions we made last year, we will actually be one of the top 10 largest software providers in the world. And not just manufacturing software, but software, period. So that's a really fantastic place to be from my point of view, and it's enabling us to do very interesting things with our own technologies. But if we take a step back, when we look at the way we look at our customers' enterprises, if you will, it really spans not just the manufacturing floor, but it starts all the way from the point of designing a product, right? And it goes all the way from product design through that production engineering, the execution of the actual production, and then the services that follow with that, both of their own facility and of their products. And so it's really a pretty significant undertaking to address this entire portion, but we firmly believe that the only way to embrace digitalization is by looking at your value chain completely holistically from end to end, because if you are not, then you're missing many of the benefits that exist between these individual domains. And one of the buzzwords that's floating around a lot, you may have heard it. If you haven't, don't worry. Many people I find are not doing it justice, frankly, but the digital twin, right? So we have this concept of a digital twin, and it really exists throughout the entire value chain. It's not just a digital twin of a machine. It's not just a digital twin of your product. It's not just a CAD model. It's really the entire value chain should be able to be cloned completely virtually so that you understand that before you ever take a step into the real world. And that's where I'm going to focus a portion of my presentation today. I want to give you guys a glimpse into what we're actually speaking to. Much of this is ripped from customer presentations I've done over the last few weeks. What we're presenting to our customers and the way we're showing them what capabilities they could have going into the future with digitalization. And so the first digital twin, if you will, is that of a product, right? So we want to understand how our product works completely. And our products that we're designing today are really quite unique and completely different than they've ever been before. And so this may look quite strange, this picture in the center, but it's showing a cross-section of a burner for methane gases and different things in the process industry. And it looks quite odd, doesn't it? It doesn't look like something that a human probably really designed on their own, and that's because they didn't. So this was using a variety of different optimization techniques and generative design tools, which enabled actually creating this really interesting shape that is the most optimized shape to achieve what that particular product is looking to do. And the reason we have this picture of a funnel on the right-hand side there is, if you look at it quite closely, it looks quite similar, if you ask me. And that's because what we're doing here is the same thing that really nature is doing with evolution, right? Iteration after iteration after iteration after iteration. And this happens millions and millions of times to produce these really fascinating designs that, quite frankly, can also only be produced by new manufacturing techniques like additive and 3D printing. But just having a nice looking design is one thing. Understanding those nice new designs is a completely different thing. So many of those acquisitions you saw were in the simulation space. So what you're seeing here are fluid flows, essentially air flows through that particular device, so that we can understand, so that we can predict the behavior of it before we've ever even touched a physical prototype. And I'll focus a little bit on the aerospace industry just for consistency throughout this. For them, the risk of not understanding how their product behaves in flight is quite high, right? You can ask Southwest Airlines about that one if you need to. You understand, though, that even understanding the details of, in this case, where the landing gear goes back up into it, there's obviously still going to be some edges there. They need to understand the fluid flow over that when a plane is flying at 30,000 feet. And additionally, also, we're starting to have smarter and smarter products that have integrated electronics. I mean, we're even working with footwear companies that are beginning to embed electronics into shoes, right? And in the process of that, one of the larger acquisitions we made last year is completely focused on electronics. So we want to take a look at the in-depth electronics, the circuit boards, the electrical wiring in those systems, and understand how they behave as well. And what that allows us to do is something really quite cool. So this is a live simulation in that this individual that you see up in the right-hand corner has a simulated cockpit for a plane, if you will, and he's pushing on pedals that are connected up to the simulations themselves. And the simulation is reacting in real time to what that operator is doing. And it's not just understanding the physical things that are happening here, it's the physics behind it, and it's also the electrical systems. So we're simulating absolutely everything that could go into deploying this landing gear for this particular plane, and we're even able to incorporate the actual human operator and do training before we even have a physical prototype completely built. And that's what we understand as a digital twin of a product, right? It's understanding everything about that product and how it's going to behave while it's being used. But of course, understanding how a product behaves is one thing, understanding how you produce it is a completely different thing. So we have this concept of a digital twin of production, and some of those same physics engines, and I just like this video because it's a nice, relatable example. That's not just that's not an animation. That's actually a physics engine operating, which is causing the domino pattern, literally, to happen within this simulation. And we can use those same tools that we use to test the physics behind our products to test the physics of the machinery that we're implementing on the line as well, because as I mentioned earlier, increasingly the machinery that we produce is much, much, much more complex. It's asked to be doing a lot more than previous machines, which only did one small task repeatedly. And so we need to be able to apply those same physics engines to those systems to understand them as well. And then though, let's talk about it at a process level, not just a machine level. So what you're seeing here is a wing assembly line with some robotics on it. And so we want to be able to virtually represent the actions that need to take place on the milling and the machining process of this particular wing. And so we can incorporate and digitally represent these particular robots on the line so that we can understand how they're going to behave when they're asked to do instructions as well. But we're not fooled into thinking that every line of the future, at least for the foreseeable future, is going to be completely automated. There will always be humans to some capacity involved in manufacturing environments. And so we don't want to just digitally represent the automated equipment on the line, we also want to represent the people on the line as well. And we can do ergonomic studies with those individuals so that we understand stress and strain and bench heights and